This next video is all about the Workbench within Improve. The Workbench is meant to provide an opportunity for a user to create and modify a set of steps to be able to solve a question or a problem. Each one of those steps could be a non-mem step, an R, an S+, a Perl, any number of different third-party tool to be able to solve that particular problem. And you can create a workflow to solve that problem utilizing multiple analyses, whether those be using non-mem, S+, SAS, Perl, or other tools. Each one of those steps could be a specific analysis or diagnostics, graphs, reporting, anything along those lines to help you get to be able to solve the particular question or problem. The analysis itself starts with an analysis tree, which you can see here, and we create that off of individual folders within the application. So you'll see here, if I right-click, you'll see the option to be able to create a new analysis tree. Let's assume for this DEF 1002, we're planning on performing a QTC analysis for this study. You'll see that Improve will go through and create a brand new blank canvas for you to be able to go through and create your workflow and generate your steps. Let's start by creating a root step. You'll see here that you have the option of selecting a given tool that you want to utilize for this step, whether that be for non-mem analysis, using R, Perl, SAS, S+, PSN, any number of various tools that are available to you. Once I've selected the tool, you'll see I come into the actual analysis step window. This analysis step controls everything about this particular step in your workflow. The first thing to note is we're going to start with non-mem. We have the capability to choose where we want to run non-mem. If we have non-mem on our local machine, maybe we have an Amazon Linux cloud that is available for us running non-mem, maybe an on-site Linux grid. I'm going to choose local. You'll see on each individual machine, there can be multiple versions of non-mem or R or S+ available to you. You can go ahead and select which version of the tool that you want to run. You'll see a few things come into the window. Number one is the actual arguments. This is actually what will be run against the, in this case, non-mem tool. The command file, which is a command script that will identify, and it'll also create an output.txt. The ignore result files is actually what files will not be brought back into the application. So for example, the non-mem.exe is a large file that does not need to be brought back in. And streamable output, these are the files that will be by default open for you while, in this case, non-mem runs, so that you can monitor the actual ongoing run and make sure that everything is running appropriately. Under the inventory tab is actually where we identify what files are we going to utilize for this step. This is a non-mem step, so we obviously need a model file or a script file and also a data set. So we'll go ahead and identify a model file, identified as the main command file. You'll see that it'll be renamed for this run, run1.ctl. Each successive run will be identified as run2.ctl, run3.ctl, etc. if it were non-mem runs. You'll also see that the file, the model file, opens in the left-hand window. This is a fully editable window where you can come through and make any modifications that you so desire. It also will show you where comments are, any code scripts, as well as open and close parentheses for you to be able to code easier in this environment. We'll also identify the data set. You'll see the data set has come in, and this data set actually is identified as a link. That means two things. Number one, it's not going to be copied and take up additional storage space each and every step. It's always going to link back to the original location in the repository. It also means that if the original location changes, let's say a data provider provides a new version, this is just linked to version 1. It's very easy to update this to version 2 or version 3 or version 4 at any given time and rerun this step with that new data set with any updates appropriate. We also have an opportunity to put in description, rationale, and any remarks for the step itself. The description is something, in this case, let's say a proportional error model. This is to allow the user can focus on what they want to do, the actual gray matter, and Improve will track and restore the who, what, when, where, and why. At this point, we've identified a model file, a data set, We've identified that we're going to run against our local machine, and specifically version 7.2 using G-Fortran. We're going to go ahead and run this, and we'll be able to monitor the results during the run. The monitoring window has opened up. This is actually a direct connection to the running environment of this step. Again, in this step, it's non-mem. It's going to show us all of the files that get created and allow us to monitor, in this case, the iterations and anything else within the non-mem environment. Once it's finished, status bar down at the lower left, which indicates that it is finished. We can look at the inventory. We'll now be able to see for this step all of the files. You'll see we have command file datasets and all of the files that have been created. We could, for example, look at the fit file, the table file that was created. Of course, we can take a look at the output.txt, which has any number of pieces of information, including the final parameter estimates, objective function value, any results identified back from non-mem. In addition, we actually parse the objective function values as well as the coordinating parameter estimates, where you can visualize them in a table, seeing the lower bound, initial estimate, upper bound, as well as final estimates and standard errors from the thetas, omegas, and sigmas. The user would likely make a decision, additional step in their workflow. They may very well decide that they want to actually create a new non-mem step with generating some modifications to the parameters, and they can rerun. All of this will be tracked within the application, and any changes in things like objective function value will be noted for the user. The user can also create R steps. So I could create a step and say I want to utilize R. Let's say in this case we want to actually generate a goodness of fit plot. We can, for tools like R, SAS, S+, that have both a batch component and a GUI, we have the capability to choose between batch or GUI. If we select GUI, it will actually open up R, and we can interact in the R window itself. I'm going to select the script. I can choose what files, let's say that I wanted to bring in from my parent step, the actual table file. And let's say I had a script that generated a goodness of fit. You'll see here this reads in model1.fit and outputs wresdist.png. Once this is complete, I can take a look at my inventory, and you'll see here that I've actually generated a goodness of fit for this particular step. Each one of these steps have information about them, including things like the objective function value, thetas, etc., that I can visualize on the tree, and it creates a sequential tree for you to track your analyses or your workflow for solving that particular problem. In addition to the workflow visualization of the tree, we also have a table of the tree as well, where I can see things like what tool was used for the step, what hardware resource, whether it be local or grid or cloud, what files were used, any comments that were identified, date and time, again, the who, what, when, where, and why, repository, who created it, where it was created, and estimates in terms of objective function value and parameter estimates for any of the non-mem step. You can export this table to utilize it in graphs and charts. You could view all of the information as well inside of the tree by going to properties and visualizing, let's say, something like description, where we can actually see the information, and we can increase or decrease the amount of information that we see inside of this visual workflow for answering a particular question. In summary, the Workbench is all about solving a specific question or problem. The user identifies what workflow, the gray matter, and Improve tracks the who, what, when, where, and why of that entire workflow, visualizing in a tree, and each one of the steps having all of the pieces of information for that particular analysis. The next video in this series will go through an actual example of solving a specific problem or question within Improve.